Hello, sir. Myself Nitin, and my topic is lithium glass batteries, which is the next generation power storage. Uh, is a part of my AET in Advances in Energy Technology. Production in the coming future, renewable grid, EVs, and electronics will have a massive boom in their expansion. So, here energy storage will play a crucial part in these industries. Lithium glass batteries are an emerging technology poised to revolutionize safety and performance and sustainability. Lithium glass batteries are a type of a solid state lithium batteries where electrolyte is a glass or a glass ceramic that is ionic conductor. Here is a cross-sectional view of a lithium ion battery. I'll be explaining this as well as the glass battery because there is no standardized diagram exactly labeled as lithium glass battery in the public domain. There are only minor changes that leads to a glass battery. Here the electrolyte is changed to glass or amorphous solid instead of the liquid. Here, the main components are the negative electrode or the anode, where the lithium ions are stored during charging, and cathode, where the lithium ions are stored during discharging. And the main component is the separator or the electrolyte. It's an ionic conducting medium that permits lithium ions to move between the electrodes while preventing a direct electric short. In this, a glass electrode design, this region is replaced partially by a glassy or amorphous solid or a separator. How it works? Here, charging. External power sources forces electrons to flow into the anode, while the lithium ions move through the glass electrolyte to the anode, where they are stored. While discharging, lithium ions move back through the glass electrode to the cathode. Electrons flow through external circuit to do their work, lighting a device or for any other purposes. Here are the standard features which distinguish between a glass battery and a normal lithium ion battery. A solid electrolyte stability and safety. Traditional lithium ion battery are liquid electrolytes, which have a risk like flammability, leakage, or a thermal runaway. While replacing it with a glass electrolyte is non-flammable, suppresses the dendrite growth. It's for some extent and is mechanically more stable. Ionic connectivity in glasses. Glass materials, when properly engineered, they have fairly high lithium ion connectivity compared to other polymers. And this glass structure can allow easier paths for lithium to opt through depending on the local structure and disorder and doping. Lithium metal compatibility. Some designs aim to pair a glass electrolyte like lithium metal anode. This can increase energy density but also poses a risk of lithium dendrite growth that may pierce electrons, and advanced glass design aims to suppress the block dendrites. Okay, let's look into the basic principle and working. Here, structure. The electrolyte structure is made of a solid or a glassy electrolyte, which can be a lithium hydroxide or barium doped lithium chlorides. Operation during discharge, the alkali metal at the anode, which is the lithium, is stripped and redeposited at the cathode. This movement of ions move through the glass electrolytes. Unlike traditional lithium-ion batteries, which uses liquid electrolytes, which can be dangerous, as I told, for it can be flammable or it can have a thermal runaway. The glass electrolyte prevents the dendrite formation and fires. Uh, uh, as I showed, there is a simple diagram showing a lithium glass cell with labeled anode, cathode, and to show the ion movement during discharge and charge. These are the recent advances in the lithium glass energy technology. Uh, Research breakthrough in glass electrolytes for faster charging and improved stability and improved reliability. In the period of 2018 to 2025, it was confirmed that ability to operate safely and for thousands of cycles in the lab. Solid state battery advances have driven both skepticism and excitement among scientists, especially regarding how energy is stored with lithium or sodium on both sides. Updates focus on large-scale applications, deeper understanding of the Fermi energy mechanism, and expanded use of sodium ion sustainability or lithium ion sustainability. These are some of the real-world applications of lithium glass ion batteries where it can be used in near future EVs. As there is a massive expansion in the EV industries, many big players like Tesla, Tata can implement these lithium glass batteries because of the long life, fast charging, and safety. And this feature makes them a very good and ideal candidate for the next gen EVs. Grid storage, high cycle life, and safety mean lithium glass can dramatically improve renewable energy storage and stabilize smart grids, which can help in powering cities and industries. Portable devices, potential for much longer device lifetime in phones, laptops, and wearables, especially if the sodium is used to reduce cost. Aerospace, their high safety profile and lightweight could eventually support satellites and drones. This leads to the conclusion of the topic. Lithium glass batteries combine higher safety, longer life, sustainability. This also comes with few challenges like growing large defective free glass electrode layers at a low cost is non-trivial, and achieving good densification, elimination of pores, and consistent ion pathways is challenging. There are a potential game changers for EV, grid storage, and portable tech, as well as a clean energy transition. Because this electrolyte is a solid glass, there is no liquid to leak and fewer side reactions with a safe. If the interface is clean and stable, internal resistance can be low and performance can approach and even outperform conventional designs if optimized.